Right, now I've been told to share. I need to share more of the work I'm doing online and show people what I'm up to. So I'm going to share this with you. This is a nice project. I love doing jobs like this. I'm going to machine this new bronze casting. Here's the old one. I do have a drawing. It's a combined driver's brake valve from an LMS steam locomotive. I think this particular one was fitted to a Stania Black 5, but they were fitted to all sorts over the years. And I've done lots of machining on these in the past, but I've never done a full casting from scratch, which would be nice. But I enjoy doing this sort of work. So it'll all be manually machined. I don't have any CNC. It's largely going to be on the boring machine, and then all these threads are going to be done in the lathe afterwards. So the first thing I will do is I'll look over the casting and make sure there's enough green on everything. Choose a start point, and then work out. Some of these details are not critical in terms of their location. They will be dimensioned on the drawing, like the spacing between these two pipe connections, for example. Not that critical. The most important thing with a casting like this, and certainly when it's in a pressure setting, is keeping the wall thickness as thick as you can wherever you go. You know, if the centre here, the core, is slightly off, I will throw the centre of the pipe fitting off to maintain wall thickness. The pipes will move around, you know, if necessary. But actually, I don't think that's going to be a problem on this. It's the customer supplied it, but it's made by the Severn Valley Railway. They have their own, I believe they have their own foundry, but they certainly do all the patterns for the heritage rail industry, and they're all brilliant. I've never had an issue with them. And a quick look over the rule shows that all these centred distances are all pretty much spot on. So I can almost choose anywhere to start without worrying too much about critical dimensions not cleaned up. That's the thing. When I was saying about these can be moved anywhere, they're fine. If there's any critical dimensions on it, they might, you know, like the bore of here, for example, for whatever reason, it might only have 30 thou of green material in it to clean up to the drawing size. It doesn't. It's got plenty in, but you know, that's where I'd start if that was the problem. Now, say this is a combined brake valve. It's because it combines a steam brake, which is this portion, and a vacuum brake, which is this portion. The locomotive itself has a steam cylinder to operate the brakes, and the train it's towing generally would be, but certainly of this era, would be a vacuum train. And this means that there's only one lever to control the brakes, and it does both the locomotive and the train together. Also works the other way in that if something in the train goes wrong and the vacuum brake applies, but either intentionally by the guard or not, or an accident, broken coupling, whatever, it will automatically apply the brake because the vacuum will be destroyed, and it will apply the locomotive brake as well. So it's quite a simple thing, but it's a good design that was carried on for a long time. So this is your vacuum chamber. These two connections here, let's get this out of the way, are your vacuum. This goes down to the vacuum to the train pipe, which goes and connects to all the carriages. This goes to a relief valve, which is basically like a safety valve to stop it over creating vacuum. Normally runs at 21 inches of mercury. This is your steam in from the boiler. So that's boiler pressure going into this chamber here. And then you've got two different outlets out of here. One to the, this one goes to the steam brake cylinder, and this one just goes to exhaust. It's a drain. So they all go down through the cab floor. Now all these I'm going to have to single point cut on the lathe. So I say I'm going to overturn them all on the borer. And then I've got something to clock up off. If I face and overturn the outside, I can then clock up off. Each one has to be done individually in the lathe, which can be a bit of a pain, but it's the only way I can do it. So some of them, of course, because they're nearer the edge, you know, the casting's going to have to spin, you know, create quite an arc as it's spinning round. So need a fairly large lathe to do it. But I'm going to do it on probably a lot of the machining on the borer, like I say. I can sit it like this, and I can do all this detail from one side. I can turn it. There's only one hole on this side to drill. I can turn it over the borer. I can turn it this side and do that. The table rotates my boring machine, so once I've set it up, that's great. These can probably be either done that way or that way. Probably what I'll do, and then I can do all this detail on that setting. So it probably are 2 settings in the boring machine with any luck, and then several on the lathe to get all the threads done. But yeah, we'll have a quick look over the casting and I'll walk you through my intention. As I say, the first thing I'm probably going to do is machine this mounting face. This is where it bolts onto the boiler. Just 2 mounting stud holes, you can see on the old one. So I'm going to machine that first. See, all the centre to centre dimensions look good on this casting. So I can, if I do that first, it's a great face to measure from, but it also means I can bolt it down onto the boring machine straight away, and then I can use that as my datum. It is a dimensioned face on the drone, of course, so I can work out all my centre lines off that face then. So that's the first thing I'm probably going to do. I might do that on the milling machine, actually. Face this off to the right height, put my 2 mounting holes in, and then go from there. And then everything else, and it works good in the future as well. If I was ever to remachine this, which sometimes they need reboring in here, I've got a nice face that I can bolt it onto, and I know that everything's been done to that face, kept it all square. So in the future, it just makes my life easier. If I ever see this valve again, I might not, but whoever does, I always like to start off with, when I've got a new casting with something like that. So it's a nice flat face to work from. It's repeatable, and it also makes life easier for me to have that, to bolt it onto the machine. So yeah, first thing I think I'll chuck it on the milling machine, and yeah, we'll take it from there. So I've got it set up on the mill. I've set on some parallels. This large face that the vacuum cylinder mounts on, because it's quite a large area, even though it's not flat, it gives me a better sort of average of getting it something like that. You can see against the column of the mill, I have measured it all. It's fairly square. I've also measured off the column this way to get this mounting face roughly parallel. I will skim this edge just lightly again, so I've got something to run a clock up off in future. And then when I'm setting up on the boring machine as well, I'll use that. So, right, get this faced off and holes drilled. Here we are on the milling machine now. Slab cutter to face it off. I don't have a slab cutter for the boring machine yet, or I didn't at this stage, so that was one reason for doing it on the milling machine, as well as having a digital readout. That makes it a lot easier to get the spacings for the holes correct, which I am doing here. Just centre drill it, 3/8 pilot, and then a finish size of 11/32, clearance on the studs, deburr the edge with a hand countersink. And now on the boring machine, you can see I've bolted it down with those holes that I've just drilled and that mounting face. So it's now facing off and then overturning these sections that are going to be threaded for the pipes to connect to. So I'm using the facing head here. So obviously this is sped up, just going in and out, facing that off and then overturning to get the diameter close to the thread size. Probably left about 20 thou on the outside diameter of these pipe fittings. It wasn't too quick. I had to do fairly light cuts owing to the tool stick out. Wasn't overly rigid, but wasn't too bad. I could probably take 20-30 thou a side each pass maybe. There's another view there. You can see there's a little bit of chatter and patterns in the finish. Not a problem, only need to be able to clock up off it with a DTI once it's in the lathe. So, and there you can have a look view through the inside. That's the speed, real speed I was cutting at. To the other side, you can see in the background, and the side I've already done. So I've spun the table around on the machine to the other side. Now at this point, I actually fitted a digital readout to the boring machine. I've got a lot of bronze casting work coming up, and it's going to save me so much time for doing jobs like this. To do this with the vernier readouts that I had before is quite time consuming and tedious, so it's much easier with a readout here. And we're drilling these to 3/8. These are where the vacuum chamber bolts onto the body. And just to finish off, a little countersink just to break the edge. And now onto the bore for the steam plug. This is quite a long, narrow bore. The plug's only a thou and a half clear in here, so it needs to be good. This is what caused the old one to be scrap. It had been overbored. It was, well, nearly final size. Here I am measuring with the bore mic. 1.060 inches is what we were aiming for. And you can see here that that's exactly what we've got. So happy with that. Right, all the work on the boring machine is done. So I've got it in the lathe to start cutting all these threads. I've bolted it to an angle plate with the machine in neutral. You can see I bolted it through the back, mounting flange. I've also put a clamp, if you can see that, on the inside. It goes through the bottom angle plate to square it up. Hopefully it'll stop vibration. I'm having to use a left-handed internal bar, because obviously as this spins round, we wouldn't be able to use a conventional screw cutting tool. As you can see, it will go here like that. Got to make sure that the casting doesn't hit the bed there. So it's all very close. Got to keep my wits about me on this, but yeah, they'll all be done in the same manner. Got my compound set at half the angle. It's a Whitworth thread, so it's 55 degrees. So I've got it down to 10, 20, 7.5. There. Mic'd ready. Yeah, cut some threads. Now I did these two large vacuum threads first, and these two are 8 TPI, whereas the rest are 11. I'll scratch on and get my size. I'll take a scratch pass and then check the pitch against thread gauge to make sure it's set correct on the machine. Now this lathe, someone in the past has removed the thread cutting dial, so whenever I'm cutting threads on this machine I have to leave the half nut engaged, but there is a reverse lever for the lead screw and feed shafts, and that only has one dog tooth, so it always engages at the same position, so you can use that to reverse the screw cutting and the feed without stopping the spindle or reversing the spindle. So that's what I've done on all these threads here. Now you see, whenever I measure threads on this job, there's no thread wires in sight. I am measuring purely off the outside diameter of the thread. And when I've turned these threads with the inserts, they finish the OD and the crest of the thread. Whitworth, of course, has a nice rounded crest, and these inserts are ground and made to such good tolerances that you can measure off the OD and get a good fit. So that's exactly what I've done here, and I'm just going to put a chamfer on the lead now. And this is how I usually finish my threads. I actually use the thread cutting tool to put a chamfer on the first turn of thread. Of course, that ends up at half the thread angle, which is 27.5 on these. Then I'll just polish it with a bit of emery to finish. But that creates a nice lead onto the machined thread. Just a bit of a close-up on that finished thread. Just wants a light polish and a deburr on either end. And that's good. I'm happy with that finish. And you can see here just how many counterweights I've had to put on to this chuck to balance the job out. This takes quite a lot of time actually, but it makes a big difference to how quick you can run the machine and how good your finish will be. And you can see here just how close I've had to run to get to the end of these threads. Now this bar here, you can possibly see I've actually had to grind, or maybe not had to, I certainly chose to grind a bit more clearance on the back of that bar to give me a bit more run off room at the end of the thread. But it's still close. Now these smaller ones are all 11 TPI, Whitworth foam again. They're all nominal sizes, which is very common on railway fittings. So these ones are, I think, 1.5/8 by 11. Have a skim over and then I'll check the thread gauges just to make sure. Happy with that, so we'll keep cutting. Now again, this is sped up with the tool setup that I've got, and this threading bar stuck out quite a way. Can't take too heavy cuts really, and with it also stuck out so far, I can't run it that quick. Vibration becomes a big issue, as does the fact that I'm on a lot of these threads I'm running up against a shoulder, so the faster I go, the more likely it is that I'm going to crash. So just take my time, and worked out quite well, this setup. And then it was just a case of repeat for all the other threads. Each one was a separate setup, of course, on the lathe, but all done in exactly the same manner. And in fact I used the same bar. I think they all end up using this internal bar setup. Right, last thread. Just clocks it up. What's your counterbalance on? There. Tiny bit of run out on the face. What we're looking at about a thou and a half maybe, but more than good enough. I'll probably face that off when I do the thread, so it's square to it. But yeah, set up with the last one. How many setups? 1, 2, 3, 4, 5, 6. 6 setups on the lathe for threading. So about a day's work just in the threads alone. There we are, getting towards final size on that last thread. So these are quite light passes, probably only a thou, maybe even half a thou a side on these last few passes, just to sort of polish the thread to size. You can see as it's spinning round how close it's getting to that vacuum chamber. You see I'm back feeding with the lead screw in reverse, as I mentioned earlier. I'll stop and give it a quick measure again on the OD. I'm sure there'll be plenty of people telling me that's not the way to do it, but it's worked so far. I think a little bit just to polish off one final cut, I think. The measure, the micrometer, and this was a 2 3/4 by 8 TPI. And you see there we're on 750, so that's done. Happy with that. Let's check again. Just a shade under 750. Thread's nice and smooth, so we'll put a chamfer on that first thread again, so disengage the half nut, keep the tool set at full thread depth, and just gently feed in and just chamfer that first thread off. It looks nice aesthetically, but it also of course removes the sharp edge and creates a bit of a lead to help you screw the components together. It just makes a nicely finished thread. And there we have it. Probably not videoed all the steps, but I give you an idea of sort of work that goes into manually machining a casting like this, a one-off. Probably not really suitable for doing on a CNC. There's so many variables when you actually come to machine it, and you touch on in different places, and you know, find that the cores have moved or whatever. You're sort of on the fly all the time, making adjustments to get it right. And you see in a few places there's a couple of burrs and sharp edges still to remove, but this is as it was, sort of off the machine really. So see that mating face there, nice finish from the borer. Now the customer did decide that they wanted me to remachine the innards from the old valve and use them in the new one, so I remachined the steam plug back down to the first size. Obviously this is on first bore. There's the plug turned down, ready to lap in, and then here's the valve fully assembled with all the components from the old valve, and it's ready to send back to the customer, complete. So there we are, just a little insight, but on to the next job.